Hey guys, this is for your worksheet part B, uniform circular motion and force gravitational. I'm going to show you how to figure out what would happen to the force if I change some variables. And the variables I'm talking about are going to be mass of object 1, mass of object 2, and the radius, which is the distance between the two centers. All right. Okay, so let's see. Let's say I have and I'm not going to give you actually any real distances or any real masses. You can figure out what's going to happen to the force just by getting some multipliers. All right. So let's say, okay, I got this equation here. That's what I'm going to be using. Okay. So right now, what would happen to my force gravitational if I doubled just one of these masses? Right? If I doubled just one of these masses, so this is M1, right? So what I'm going to do is I'm going to go force gravitational equals, I'm just going to plug a 1 into everything, okay? So G is going to become a 1. Mass 1, I did times 2, right? I doubled. So right here in mass 1, I'm going to put a 2. You see that? Mass 1 got doubled, right? So I plug in a 2 there. Okay, mass 2, I didn't change, so it stays as a 1. So the radius hasn't changed, so guess what I put in there? 1 squared. I'm just copying the equation, but I'm only multiplying the thing that I changed. So mass 1 changed. So what's going to happen to all this? 1 times 2 times 1, you put it in your calculator, you get 2 over 1 squared. 1 squared is just 1, so 2, right? So my force would be 2. It would be 2 times greater. 2 times greater if I doubled one of the masses. That's simple, right? Okay, now, let's erase all this junk. All right, what would happen if I if I doubled the distance, between the two. Okay, so now with distance, is it going to affect mass? No. It's going to affect the radius, right? The radius between the two. So I'm going to do the exact same thing. Force gravitational equals. I'm plugging in a 1 to everything. And what did I change, right? I changed the radius. I did a times 2 down here, right? So 1, the masses are the same, so I just put a 1, divide by radius. What did I do? I put a 2 because I doubled it. I have to square it, right? So 1 times 1 times 1 is 1. And what's 2 squared? 2 times 2 is 4. So what happens to the overall force? It decreased by a fourth. It's only a fourth of what it was originally. Okay. Okay, last one. Here's the last manipulation I'm going to do. Let's say I made it a third of the distance. Right, I brought them really close together. Do you expect this to go up? Yep, you bet. So this is what's going to happen. This is the toughest one, so you got to kind of pay attention a little bit. Okay, so am I changing the G? No, the gravitational constant is the same. Did I change the mass? No, so it stays as a 1. Oh, this is now going to be a third, right? Put a third down here. Okay, third. Mass hasn't changed, and I'm going to divide. My radius is now a third of what it was, right? 1/3. You can put this in your calculator. Okay, so 1/3 squared, you have to square the top and the bottom, right? So now I'm going to have 1 times 1 times 1 over, what's 1 squared? 1. What's 3 squared? 3 times 3 is 9. When I divide by a fraction, I have to actually, I can multiply by the reciprocal, right? So 9 over 1. So what happens when I decrease it by a third is I multiply the force by 9. That's crazy. Okay, and that makes sense. This is part of that inverse square law.